Thank you for joining our session on how Techcombank modernized data and analytics using serverless. My name is Korkut Güle, and I'm a senior consultant in data and analytics in professional services for Amazon Web Services. Our organization specializes in speeding up customer outcomes by delivering on all of the promises of the AWS platform and helping enterprises turn cloud technology into business outcomes. For most of my career, I have worked as a software engineer and a software architect, which have helped me to become intimate with the implementation challenges of the modern enterprises face. In my capacity with AWS for the past 4 years, I have had the privilege of designing and implementing data and analytics programs that have helped enterprises across ASEAN. In today's session, we will be talking about how we approached and worked with our customer to build the desired solution and the role of the professional services in that journey, and the journey itself, what future looks like as the technical and business landscape evolves for our customer. We'll start with the role of the professional services and how we approach our customers' objectives. Most of the IT dollars are still being spent on the on-prem world today, yet enterprises are increasingly having a cloud-first strategy. This creates an interesting challenge. This defines how AWS professional services engage and partner with our customers for their success. Getting the cloud is not just about technology. Enterprises cannot hire and train fast enough. Customers want or need to be able to operate in the cloud, but may need to manage on-prem simultaneously. And while cloud security is front and center, particularly for the regulated industries, at the same time, customers need more and more flexible approaches to the building their cloud skills. We have also observed that rapid innovation is one of the main reasons customers come to Amazon Web Services. Let's talk about how professional services aims to help AWS customers. Professional services' special sauce is to help customers accelerate business outcomes is multifaceted. We put security front and center. For us, security is job zero, always. We believe that rapid iteration is the goal and not a big bang approach. And we seek to understand the resource challenges and build a plan to address the customer's unique situation. Our analytics capability is broad and deep. We try to bring expertise from other domains as well and constantly improve our understanding. Professional services has a wide variety of specialists to draw from. AWS Professional Services uses a unique methodology based on Amazon's internal best practices to help you complete projects faster and more reliably while accounting for the evolving expectations and dynamic team structures along the way. This is how we approach. It starts with a customer-centered approach to what is the problem, and we work with the customer to understand their problem space. We frame or reframe the problem by gaining a full understanding of the questions, scope, and the overall context of the challenge. We design, test new hypotheses, and pilot innovative ideas. With the result of a successful pilot, we can then help scale the product and the service, and over time, refine and optimize. AWS Professional Services help you achieve specific outcomes related to enterprise cloud adoption. Each offering delivers a set of activities, best practices, and documentation reflecting our experience supporting hundreds of customers in their journey to the AWS cloud. In professional services, we work backwards from the customer's business objectives. We spend time and effort to identify such objectives. We strongly believe that doing this hard work right now will save us more work later on. In this case, our customer was undergoing a rapid digital transformation, including migration of applications and databases onto AWS. When our customer approached us about their analytics workloads, but not being sure about if AWS was the right place to handle such workloads, we have worked with our customer to identify a business objective to focus on and deliver value early on. This also helped our customer to identify key areas where we can help them. One of the business objectives we have focused on the current credit underwriting process, which was not supporting our customers' needs. Every business objective should raise the question of what is the cost of doing nothing, why this objective is important, how can we measure if we are doing the right thing, How can we ensure we are spending our effort on the right questions? During our sessions together with our customer, we have identified why this business objective mattered. We have identified that solving it would have helped speeding up decision-making process and packaging existing products better, aiming to delight bank's customers and improve outcomes for the bank itself. However, technical challenges remain. Was AWS the right place to build such a product? Customers' business objectives, when translated to the technical outcomes, was to build a scalable, configurable, and an extensible platform. In summary, we have worked backwards from the customer's business problem to identify the aspects of why is this problem important to solve, and also what are the current blockers to solve it to craft our technical approach. When we looked at the technical outcomes that we should be aiming for, it became quite clear that not only our customer needs a structured approach to build services or a data lake approach to answer specific analytics-related questions, they also need a comprehensive and secure data strategy. Only with the combination of these goals, our customer would have achieved expected longevity and effectiveness that they are after. This required us to follow a modern data strategy for our customer. Now let's look at how our specific approach and guidance around the modern data strategy with governance and security and serverless approach helped us to build a compelling solution for our customer. Customers have data stored in various silos, which leads to inefficiency, scalability, and governance problems. The ability for organizations to easily access, combine, prepare, analyze, and perform machine learning with their data in an agile, scalable, secure, and a cost-effective way is still too cumbersome, time-consuming, and expensive. Taking a one-size-fits-all approach to analytics eventually leads to compromises. Your customers need the right tool for the right job. A modern data strategy lets customers break down data silos, empower their teams to run analytics or machine learning using their preferred tool or technique, and manage who has access to the data with proper security and data governance controls. With a modern data strategy, organizations can move any amount of data from various silos into an Amazon S3 data lake and store their data in S3 using standards-based open data formats to avoid being locked in any proprietary data format or approach to analytics. Customers also get purpose-built analytics services for their unique analytics use cases. We are architected to be the most secure cloud computing environment. Our core infrastructure is built to satisfy the security requirements for the government agencies, global banks, and other high-sensitivity organizations. AWS databases are 1/10 of the cost of the commercial databases, allowing you to save time and cost. 15+ purpose-built cloud databases allow you to build use case-driven, highly scalable, distributed applications suited to your specific needs. This leads us to data lakes and purpose-built data services. Data lakes built on Amazon S3 lets organizations store and retrieve any type of data at any scale. Storing data in standards-based open formats makes it easy for any analytics or machine learning service to work on the data. It also eliminates the need to unnecessarily move, transform, or reformat the data in order to get value from it. Customers can use Amazon Aurora for processing transactions at high speed, or Amazon OpenSearch for storing and analyzing large volumes of log data at low cost. Amazon Athena supports federated queries, the ability to run queries across data stored in operational databases, data warehouses, and data lakes to provide insights across multiple data sources with no data movement and no need to set up and maintain complex extract, transform, and load pipelines. With the modern data strategy approach, organizations can use capabilities like AWS Glue Elastic Views to effortlessly move and keep the data in sync between data lake and the data warehouse and purpose-built stores. AWS Lake Formation provides an easy way to centrally define and manage security, governance, and auditing policies all in one place. What about data protection? Why use data protection on AWS? Customers around the globe are using AWS in diverse ways for outcomes. Data protection drives better business outcomes by providing protection for IP, customer information, automating repetitive protection, and monitoring tasks, while providing visibility and inheriting global security and compliance controls. For organizations to manage data in the cloud, they need a secure cloud environment with the ability to manage the privacy controls of their data, control how their data is used, who has access to it, and how it is encrypted. AWS data protection services such as AWS Key Management Service, AWS Secrets Manager, AWS Certificate Manager, and AWS Cloud HSM are designed to be highly integrated with hundreds of AWS services, with granular controls over access and policy enforcement, and a highly secure foundation. Building a data strategy is not complete without thinking about services that will consume the data. However, monolithic application formations usually need to be broken down. Event-driven serverless architectures enable your applications to seamlessly scale and burst so that they can handle virtually any demand, benefiting from pay-as-you-go pricing and minimal operational overhead. But how all these come together? One thing we learned along the way is building modern data platforms involve many steps as they require new thinking at times and new approaches suitable to scale, now possible with the cloud. There are challenges to implementing a secure and modern data platform. One of them is repetitive, multi-step actions that now you have to take. Setting up storage, moving data, cleaning it, configuring security policies, and making data ready and available to serve analytics use cases. Recognizing these challenges and repetitive patterns, we started a professional services open source initiative called Serverless Data Lake Framework. This is a solution consisting of components, pipelines, and constructs deployed as a code that has been built in order to accelerate the deployment and customization of a modern data architecture in the cloud. Serverless Data Lake Framework, or SDLF, aims to achieve several outcomes by expressing your intentions in templates: data protection, workload monitoring, compliance status, identity, resource management, permission management, data cataloging, ingestion, and advanced analytics with greater insights. SDLF provides several features out of the box. SDLF is entirely managed through CI/CD pipelines. At no point is interaction with the AWS console is necessary, and in fact, it's discouraged. And using version control ensures that any change to the data lake is scrutinized before it enters the production. With this deploying and removing a customized production-grade data lake can be done in minutes, and we can scale to multiple accounts and environments easily. This is in comparison a manual approach which would be tedious, slow, and prone to errors and unable to scale. There are a couple of service families we use in SDLF. AWS CodeStar gives the overall ability to deploy and maintain the whole pipeline that is managing our infrastructure, our data processing code, and the configuration of services. While AWS Lake Formation provides overall control on your data lake with role and attributes-based access control, AWS Glue with crawler, and AWS Glue Data Catalog provides metadata collected from your data stored in the data lake. Serverless Data Lake Framework makes extensive use of workflows implemented using AWS Step Functions. AWS Step Functions are a great addition since, with the recent update, allows you to access nearly all native AWS services to invoke them within a workflow. Amazon S3 is at the heart of our storage, providing cost-effective, resilient, and secure data storage controlled by relevant policies and governed by lake formation. We can have additional services added into our data pipelines at any time, such as Amazon Kinesis or Amazon Managed Services for Kafka for streaming data, Amazon Athena for ad hoc queries, search capabilities via Amazon OpenSearch, and Amazon EMR for large-scale Hadoop-based workflows. Now, let's look at a reference architecture. It is important to understand that this is just one possibility to use to illustrate the orchestration process within the framework. Each team has a full flexibility in terms of the number, order, and the purpose of the various stages and steps within their pipeline and in their architecture. This example workflow is nothing fancy. We receive a file, apply a series of transformations to it, and finally store it in a location as refined data. Since this entire architecture is deployed via STLF, it allows you to change, add, and remove sections of it by changing your deployment scripts. Let's briefly parse this architecture. It starts as a file lands into a bucket. An S3 events notification is created and placed in a queue. Then, a message is picked up by a Lambda, which routes this to the appropriate STLF team-specific pipeline. Then a first stage of the pipeline is triggered. Initial step in the processing is to update the object's metadata catalog, DynamoDB table, with the details about the landed object such as S3 path, timestamp, before a light transformation is applied. The code for this light transformation would have been previously pushed into a code commit repository by a data engineer and potentially have gone a code review and testing phase before entering production. The final step is to update the object metadata catalog with the output from the transformation and send the messages to the next SQS queue. Following that, at a configured interval, a CloudWatch event rule fires a Lambda, which checks if there are any messages in the queue sent from the previous stage. If so, it triggers a second step function. This is again an example, and we can chain as many events as we want. This time, a heavy transformation is applied on a batch of files. This heavy transformation can be an API call to an analytical AWS service such as AWS Glue Job, Fargate Task, Amazon EMR Step, or an Amazon SageMaker notebook. The state machine waits for the job to reach an end before output is crawled to update Glue metadata catalog. A data quality step leveraging data brew or DQ can also be integrated at any moment. Now, let's briefly talk about what kind of constructs STLF relies on. It starts with a team. A team is a group of individuals that wish to onboard into the data lake. It can be a pizza team of developers or an entire business unit, such as the marketing or the finance department. They are responsible for their pipelines, datasets, and repositories, which are unique to the team and completely segregated from the others. Teams are also isolated from both an operational and a security standpoint using the least privilege IAM policies. A team can implement one or more pipelines depending on their needs. An STLF pipeline is a logical construct representing an ETL process. Each pipeline is divided into stages which map to AWS step functions. Each step function orchestrates the process of transforming and moving data to different areas within the data lake. There are two main advantages of using step functions as an orchestration layer. They are 1, serverless, 2, connected to the entire AWS universe, simplifying integration with the other services on the platform. As many stages as necessary can be defined and modified for the pipeline. An STLF dataset is a logical construct referring to a grouping of data. It can be anything from a single table to an entire database with multiple tables, for an example. Some examples of datasets are a relational database with multiple tables, a group of files from a data source, or a streaming data source. These constructs, referred as the infrastructure code. Transformations, on the other hand, represents the application code that run within the steps of an STLF pipeline. They include instructions to make an API call to another service or outside the AWS platform, store a data set and pipeline execution metadata in a catalog, collect logs and store them in OpenSearch or any other logic. Once transformation and other application code is pushed into team repository, it goes through a code pipeline and can be submitted to testing before it enters the production. And as we have hinted about before, everything in STLF defined as a code, in this case as a CloudFormation script. All required changes can be done in code, including new pipelines, changes in datasets, and workflows. You can set patterns and rules for allowed values and ranges, and create code repository workflows, depending on your software development lifecycle. There are many other details about STLF that you can try it yourself. Please check out the STLF and the tools that work with it at a publicly available workshop at stlf.workshop.aws. Now, I would like to invite Richard Tarzali, Head of Data Engineering in Techcombank, to describe from his point of view how the journey was like and what we have achieved together.
Thanks, Korkut. Hi, everyone. Thank you so much for joining my session on how did we deliver a countrywide underwriting solution in a quarter. My name is Richard Tarzali, and I'm the head of ML and Data Engineering and Delivery at Techcombank Vietnam. Amongst other responsibilities, I oversee the delivery of the bank data lakehouse. I wrote my first game when I was 12, and I'm super passionate about building software that changes millions of people's lives for the better. In my career spanning 25 years, I've been working at a handful of distinguished companies and startups, including setting up my own. So let me tell you a little secret. My heart will always be with startups. There's just nothing quite like it. Techcombank is a +1 billion pre-tax yearly profit bank and one of the most prominent banks of Vietnam that won many awards. To mention some, Best Bank in Vietnam, Best Company to Work for in Asia, Best Payments Bank, Most Recommended Transaction Bank in Vietnam, Best Treasurer, and overall, one of the best Asian companies to work for. These numbers are highly representative of what happens in Vietnam retail banking currently. So let's dig in. We finished the year with 83.4% of our total transaction count being in retail e-banking. We also got a 32.3% hike in customers embracing digital and a massive 70% increase in such transactions in 2021. In a nutshell, the digital banking adoption rates continue to climb rapidly in retail. While customer obsessed, how can we provide consistency across all the major customer profiles we serve and still massively scale in the mass, small, and micro segments? We have affluent, mass affluent, and mass as individuals on the left side, and large corporates, medium, small, and micro enterprises as institutions on the right side. On the top of the pyramid, it is about extreme customization and value creation. On the bottom, it is about best price, micro segments, product bundles, recommenders, handholding, and growing our customers. Well-done analytics enables scale. Think of machine learning as an enabler of adaptive decision-making at scale with propensity, segmentation, recommenders, next best offer, next best action, underwriting, customer lifetime value, and other models. At the beginning of last year, all 150 of our services were still running on premises with outpaced analytical capabilities. But that changed rapidly as we picked up AWS in March, signed the papers in May, and the rest is history. We chose AWS for their customer success-centric mindset and their very mature cloud service portfolio served in a well-integrated ecosystem. We have also found organic interest from the Vietnamese talent pool to prioritize learning AWS technologies over other cloud vendors. After picking AWS, we devised a 3-year plan on 2 major independent work streams that we further broke down into smaller ones. One work stream focuses on the cloud migration for all our systems, and the other on building a data lakehouse from scratch and sunset what we have on premises as soon as possible. For 2021, the focus was on people, data, processes, and foundation in general. In addition, this year's focus is engagement, meaning customized product lines, loyalty programs, digital marketing, better products, and services all around. And next year, it's all about expanding. Even if 2021 was all about foundation, we did manage to sneak in a few products. While building the foundations of the lake, we also delivered an underwriting platform amongst others, which I picked as the use case for you today. Why retail lending? Just look at the graph on the right side. While corporate lending, which comprises few large volume contracts, is a very stable business, retail lending shows exponential growth. Retail loans include auto loans, mortgages, credit cards, and personal loans. The architecture looked like this in mid-July. In early July, we got our first development account open under our AWS root account. 3 months later, we went live, thanks to all the support provided by AWS and their professional services. If I managed to keep it light on the content until now, here I am overwhelming you a little bit. I have left out so much from this slide. Still, I don't touch on CI/CD, multi-region and availability zone support, firewalls, transit gateways, and the entire landing zone. Let's scan through from left to right. I distinguish three kinds of data sources: on-premises, over the internet, and AWS, but in a different account or VPC. For over the internet sourcing, we use EKS, where we have different HTTP clients, SOAP clients, and many others. We have a Flink Beam cluster pushing batches and micro batches of data into the raw zone S3 buckets from on-premises. The payload is encoded in different formats depending on the source systems. Finally, we employ Kinesis to export data from Redshift into our S3 buckets from other AWS accounts. Once the data is in the lake in an S3 bucket, we get a notification that wakes a Lambda function that starts an AWS step function workflow. The main workhorse in these step function workflows is Glue, where we rely on both the crawler processes and the catalog processes to keep track of what we're moving through the zones. Staging contains the decoded payloads, while the curated zone holds the cleansed, harmonized, enriched ETL data into our enterprise data model. We specialize per business unit and use cases having many insight zones. It starts with S3, then prepared and stored via Glue into highly specialized data stores. In this case, Elasticache, AuroraDB, and DynamoDB for time series. We ended up implementing our own time series engine on top of DynamoDB, which can do all sorts of fancy series merges, aggregations, and transformations. Implementing that took 15,000 lines of Scala code. Finally, we configured DAX on top of DynamoDB to improve our performance. We deploy our online ML models as EKS pods. The GraphQL service employs them, which is queried synchronously by the underwriting workflow engine. In addition, we use MSK for asynchronous batch processing and reverse sourcing from the workflow engine. We use Athena on top of the curated and insight zones, which together with AuroraDB serves as the SQL interface for the BI platform's different dashboards and reports. We picked Scala, Python, and Rust as programming languages. Everything was developed and delivered on the cloud, except for a small cluster on premises, which is necessary to source data from relevant systems. I have never seen something go from 0 to serving customers at this scale in a single quarter. The benefits are tremendous. Before this, it was an entirely manual process involving agents, officers, and other HQ personnel, and now it is fully automated. Risk officers only tweak the workflow and overall parameters as needed. There's no more need for a branch visit. Applying for a loan means a single tap in the app. The decision, including opening an account, arrives in less than 2 minutes. Speaking of the decision, this is now done on many more data points and much more longer history, relying on fresh data. So the underwriting is much more accurate and the risk management improved for these loans. We went from capping out at hundreds, maybe low thousands of applications per day to scaling up to 800,000 applications per day. Since we delivered this to production, many other products went live. For us, the following steps revolve around finalizing the CAP architecture, solidifying our ML pipeline, and enforcing healthy governance. Another central focus area is delivering as many self-serve capabilities as feasible to democratize data and analytics. I'm currently working with and enabling all the projects I highlight here and more. It's been a short and very intense journey so far, but seriously, there's no way we could have achieved so much without the passion, support, and true partnership of the beautiful people at AWS. Thank you for your attention. It's been an honor presenting to you today. Back to you, Korkut.
So, what's next for our journey with our customer? We are already looking at how efficiently deploy data mesh strategies for bringing together different business units. How can we comprehensively answer very important governance questions at scale, bringing self-service environments for data scientists and business users. These are shaping the future direction of the platform for our customer. Thank you for attending to this session and listening to our journey. Before we close, few last things. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. Attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. validate your technical expertise with AWS, and use practice exams to help you prepare for AWS certification. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and the services you would like to know more about. So please do take the time to fill out our survey and let us know what you think.